Hello class, I hope you're all doing well today. I want to start off our virtual learning here today with finding roots and zeros of polynomials. So let's first start off with some definitions. The root of a polynomial is the root of the solution to a polynomial equation, whereas the zero of a polynomial is the input or x value of a polynomial function that makes the function equal to 0. You should take a moment to pause this video and write down these definitions. Now let's try looking at some examples. Now in this example here, I know I'm finding roots and not zeros because I have an equation set equal to 0. It's not in function notation. Well, since my equation set equal to 0, I can apply the zero product property where I set each factor equal to 0. So I'd write 2x minus 5 equals 0. X plus 3 equals 0. And x minus 1 equals 0. And then I would solve all three equations to find my roots. So looking at the first one, I'd start off by adding 5 and get 2x equals 5. And then divide by 2 to get x equals 5 halves. There's my first 0. Looking at my second equation, all I have to do is subtract 3 and get x equals negative 3. There's my second 0. And for this equation, my final and third 0 is x equals 1 when I solve my third equation. Take a moment to pause this video and copy down the example. Now let's look at an example of finding the zeros of a polynomial function. I know it's a function because the f of x here at the beginning tells me it's in function notation. The first thing I want to do is rewrite my polynomial function as an equation set equal to 0. 0 equals the quantity of x plus 4 times the quantity of x minus 7 times the quantity of 2x minus 1 squared. Now that I have an equation set equal to 0, because I'm finding the 0 or x-intercepts of the function, I can treat it just like my other example from before. I'm going to take each factor and set it equal to 0. X plus 4 equals 0. X minus 7 equals 0. And 2x minus 1 equals 0. Now, although this one's squared and it has two factors, it means it's 2x minus 1 times itself. I only have to solve it once because I would end up with the same solution. Looking at my first equation, I would solve it and get my first 0 or x-intercept as x equals negative 4. My second 0 or x-intercept is x equals 7. And my final 0, I would start off by adding the 1 and get 2x equals 1, divide by 2, and I get x equals 1 half. Take a moment to pause this video and write down the example. We went through with finding the roots or zeros when the equation was in factored form, but what if it's not in factored form? Well, it's going to be the same step. So I'm going to first off rewrite my function by setting it equal to 0. So remember, I'm finding the zeros or x-intercepts, which means that the f of x or y value is always 0. Okay. The first thing I notice about this equation is that I have 4 terms. If I have 4 terms, that means I would first try factoring by grouping, which in this case would fail. So when factoring by grouping fails, I go to using the rational root theorem. So that's where I find my p over q. Remember, p are factors of the constant term 3. So factors of 3. And q are factors of my leading coefficient 5. So I would end up with plus or minus 1 and plus or minus 3 over plus or minus 1 and plus or minus 5, which means I have 8 possible rational roots to test. My possible rational roots would be plus or minus 1 and plus or minus 3. And I'd also have plus or minus 1/5 and plus or minus 3/5. Remember, first to determine which of these 8 possible ones are actually a root or a 0, I need to use synthetic division to test. So when I set up my synthetic division, I'm going to take my coefficients here, 5, -7, -1, and 3, and I'm going to choose one of my 8 to possibly test. I'm going to start off and just try 1. Using synthetic division, remember, drop down the first number, multiply the 5 by the 1 up here to get 5, add -7 and 5 to get -2, multiply by the 1 to get -2, add to get -3, multiply by 1 to get -3, add to get 0. 0 is what I wanted, which means that 1 is a 0 of my function. Take a moment to pause this video and write down what we have so far before moving on to the next slide. So looking at the work I've done with the synthetic division, now knowing that 1 is a 0 of the function, that would mean that x minus 1 is a factor, so I can use this to factor my function. So I can rewrite it as f of x equals the factor of x minus 1 times 5x squared minus 2x minus 3. But I'm not done factoring because I have a quadratic trinomial, so I'd use my diamond method and look for factors of -15 that sum to -2. Well, I would find out that that is -5 and 3. So now I can create my area model to factor this. Remember, just look at each vertical and horizontal pair of numbers to find their greatest common factor, and you will factor this using the area method. So now I have my function completely factored. Take a minute to pause the video and write down what we've done up to this point. So now that I've used the diamond method, I can write my entire factored function. F of x equals x minus 1 times x minus 1 times 5x plus 3. I can condense it down and write it as f of x equals x minus 1 squared times the quantity of 5x plus 3. Now to find the zeros, set the function equal to 0 and apply the zero product property. So I would write my equations, x minus 1 equals 0 and 5x plus 3 equals 0. Solving both of those equations, I would get that my first 0 is x equals 1. And on this equation, subtract the 3, get 5x equals -3. Divide by 5x equals -3/5. So my zeros of this function are 1 and -3/5. Take a moment to finish copying down this example. Write down any questions you have, and I will see you in the Zoom meeting shortly.